We're going to find different quadratic graphs and different cases for a number of x-intercepts. So just imagine we have a quadratic. We have a parabola graphed here. Here, I'm just going to make one up. Here we go. There's a parabola. Okay? How many x-intercepts does that particular graph have? Yell it out. 2. There's one here and one there. They're on the x-axis. What if I turn the graph upside down? Could there possibly still be 2 x-intercepts? Yeah. So one case that we have for x-intercepts would be 2. Now, we're not talking about the y-intercept like as learning it. We should already know about the y-intercept. We've been practicing a lot. How many y-intercepts does the blue graph have? 1. Right there on the y-axis. How many y-intercepts does the pink one have? 1. Where is that? Okay, so parabolas, they get wider and wider and wider as they go. So where you can't see it yet, eventually just way up there, it's going to get closer and somewhere across. Okay, just like way up there. So there's one y-intercept. Okay, I have another scenario. Let's say this is my parabola. How many x-intercepts are there? 1. What's special about this parabola and the x-intercept? Cavell. Yeah, what's special? Why does this one have 1 and these have 2? Because it is the vertex, yes. If the vertex is the x-intercept, there's only 1. So another scenario could be if it opens down, the same thing could happen. So that would just be 1 x-intercept. So that is a case you could have, 1 x-intercept, if it's the vertex. If it is the vertex. And I didn't make any of these obvious, but how many y-intercepts would each of these graphs have? Everybody. Corey. Yes. How many y-intercepts will the blue or green, not green, pink, blue or pink one have? 1. Always 1 y-intercept. Okay, there is another scenario. Last scenario. What if in the blue one, the vertex is above the x-intercept and it opens up? Or a pink one, the vertex is below the x-intercept and it opens down. How many x-intercepts will we have? 0. So we could have no x-intercepts. That's another scenario. But how many y-intercepts? 1. So for all cases, these are all cases. There's no 3 intercepts for these. These are all the cases. There's always 1 y-intercept. There could be 2, 1, or none x-intercepts. And then how do we find the y-intercept? Remember, to find the y-intercept, we make x 0. And then we solve for y. To find the x-intercept, we make y 0. Solve for x. So when you're finding the intercepts, you make the other letter 0. And that is going to be the same for every single chapter in every single math book. Not just this math book, every math book ever, or course. So today, this is what your assignment is going to look like. Only these 2 questions are more challenging than the majority of the questions I gave you on today's assignment, okay? So I'm giving you harder examples. When you go to do your assignment, it's going to seem much easier and less steps. So we are going to identify the vertex, the axis of symmetry, and the y-intercept, which was what we did already on our assignment 2 days ago. Then we're also going to find the x-intercepts. That's new. Graphing it, we've already done that. So the only thing new today is finding the x-intercepts. We need to make sure we're sketching an accurate graph, which I'll go over that. So this, I'm not going to make it super challenging. We haven't learned much. All we've learned really is vertex form. So this is vertex form. So Gavin, can you tell me the vertex?
It'd be -3/8.
You're half right. 3/4 right. Ryan, can you help him?
3/8.
What did he do wrong? Oh, Gavin's shaking his head. He's like, yep, I know what I did. Yep. Yeah. So we need to make sure the horizontal is opposite. So +3/8. Good. And then because of that, our axis of symmetry, Brian, can you do the axis of symmetry? Very, very good. X equals 3. And somebody help, not Brian, but somebody else help. Can you explain where Brian got that number from? Is there somebody in here before I just cold call on you? Derek, can you explain it?
The axis of symmetry is the x and the vertex.
That's where the 3 came from. Where did this x equals part come from? It has to be an equation because it is a line. It's a vertical line. It's got to be x equals. It always is. It always is. Okay. So if you've been doing your assignments and checking your answers, you will know that. If you haven't been doing your assignments, then you will not know that. Next is y-intercept. That is where I was using the f of 0 to plug in 0 for x. So start with negative. Yeah. So -1/2, 0 minus 3 squared plus 8. So we're going to simplify this. We get -1/2. I got -3 squared plus 8, which gives me -1/2 times +9 squared. Oh, I did something wrong. Not squared. Plus 8. Half of 9. Anybody know half of 9? 4.5? Okay. And if I have a -4.5 and I go +8, it's going to be positive what? 3.5. Yeah, I don't know who said that, but thank you. Who was it? Oh, that was you, Jeff. Okay. Now, if we put this in Canvas, you can't put it in as a mixed number. So just to remember, if you do it as a mixed number, then you have to take like 2 times by 3 plus 1 over 2. So it'd be 7/2 is what it would be. So our y-intercept is 0, 7/2. Ooh, also remember it has to be an ordered pair. Remember, it has to be an ordered pair. 0, 7/2. And then the new part, x-intercept. So to make an x-intercept, I'm just recopying the question because I can't keep scrolling up and down. You guys don't have to do this unless you want to. To make an x-intercept, we make y 0, and y right now is f of x. So we're going to make that 0. And now we have to solve for x. And this is where we started today's lesson. So this is the kind that I guess we're practicing new this year. So we need to peel off the layers until we get x by itself. What's the first thing that we need to do to both sides? Nathan, do you have a clue?
Divide.
Did you say divide because somebody over there said divide? Okay, hold on a second. If you're not sure, divide is not the correct answer, by the way. If you're not sure, think about, here's my x. What am I doing to the x in order? First, I'm subtracting 3. Then I'm doing squared. Then I'm multiplying by -1/2. And then I add 8. By order of operations, parentheses, exponents, multiplication, addition. So what's the last thing that's being done? That's the first thing I need to get rid of. So I need to subtract 8 first. Yeah. So now I have -8 equals -1/2 x minus 3 squared. So now we need to get rid of that times by -1/2. Yanzi, do you know how to undo multiply by -1/2? Yes, correct. To get rid of multiply by -1/2, you're going to multiply by -2. That's going to make it a positive. And 2.5, 2 times 1/2 makes 1. We're trying to make it a positive 1. So we're going to multiply both sides by -2. And that cancels. So now I have 16 equals x minus 3 squared. Jacob, could you help me out on the next step?
Square root be x minus 3 and 16.
Okay.
And the plus and minus is 16 now.
Yes. So I'm going to plus minus square root. My next step is plus minus square root. Got to do the plus minus. When we do the square root, the squared part and the square root, they undo each other. That's why we use square root, so that they would undo each other. On the other side of the equation, this is plus minus 4. Do you guys know where I got a 4? I don't want to assume. 4 times 4 is 16, or -4 times -4 is 16. So that's where I got both plus minus. All right, so now we can add 3 to both sides so we can get x by itself. So I have plus minus 4 and then add 3. So now I will separate x1 and x2. We have 2 answers. Positive 4 plus 3, -4 plus 3. And I did those quickly. All right, I just went through a ton of work, but what was I trying to find by doing all of this work just now? I'm trying to find the x-intercept. So I plugged in 0 for y. Is this how I write an x-intercept? Jackson, how do I write an x-intercept? You can just tell me what to write if you can't remember the name of it. Okay, so there is 2 x-intercepts. So I'm going to have 2 completely different ordered pairs. What did we put in for y? The original thing we did. We put 0 in for y. So in both of my ordered pairs, y is 0. So I've got 2 ordered pairs. I am also going to write them left to right. So I'm going to write these left to right, which just means least to greatest. So my least is -1, comma 0, because that's the y value. And then my greatest is going to be 7, comma 0. And because they're both answering the same thing, I just put them in fancy brackets. Okay. So that's how you're going to write your 2 x-intercepts. They're 2 separate ordered pairs. Now we just need to get everything on the graph. I've got, do I need to renumber my graph? I don't. All my numbers will fit. 3, 8 is our vertex. My axis of symmetry is that mirror line that goes through the vertex, x equals 3. My y-intercept is at 0, 3.5. My x-intercepts are at -1, 0, and then +7, 0. And how many points do I need minimum? 5. How many points do I have? 4. Could I get another one somehow quickly, really fast? Anybody? Besides these two boys. Love you guys. Jacob.
Reflection of the axis symmetry for the middle coin.
Yes. So I'm going to change your words, but yes. We're going to do a mirror point for the y-intercept. We just use that mirror, that axis of symmetry, like he said, and we're going to mirror this y-intercept here. And then we have more points. Now, we have 5 points. We're good to go because I gave you a question that gave you 5 points or 4 points. But remember, if you don't have that many points, that you have other things you could do. We could make a transformation table to find more points. You could just pick a point and plug in an x. Plug in a value for x. So let's see. I don't know what, when x is 1, I don't know what y is. So if I wanted to, I could do f of 1. I don't know if it's going to be a nice answer. I'm just saying what we could do. Just making sure everybody knows that we have options if you don't have enough ordered pairs. Because I know there's going to be some questions that you'll need to find more ordered pairs on. So 1, 6 is another ordered pair. And then that actually gives me 2 ordered pairs because there's a mirror. So you can find more ordered pairs if you need to. And then if there's no stretch or shrink, you could just like use the pattern from our original, what's that thing? The parent function. All of those ways that we were talking about graphing the other day still apply. But minimum 5 points. So that's the lesson for today. We're just going to do it again for practice. Okay. If I go too fast, I posted, I think I posted it already, my notes from my last class on, and if I haven't, I will post my notes on the module for today. All right, so number 2, first thing we need to do is, what is the vertex? I'm going to call on people though. Jacqueline. This is what I heard. I don't know if this is what you said. Is this what you said? It's -2, right? -2, -1. That is the correct vertex. Axis of symmetry, Sela. -2, yeah. X equals -2. Y-intercept. Maddie, you don't have to tell me the answer for the y-intercept. Just tell me, how do I find the y-intercept? Yeah. So we're going to plug in 0 for x. So I'm going to do g of 0. So 4 times 0 plus 2 squared minus 1. So 4 times 2 squared plus 1, which is 4 times 4 plus 1, which is, oh, it's not plus 1, it's minus 1. Sorry, I copied the wrong thing. There we go. 17. No, 15. I really want it to be the other way. 15. And then we write that as an ordered pair, 0, 15. Am I going to have to count by different numbers on my graph? Yeah, as soon as you see that 15, you know you're going to have to count by something else. Let's go ahead and find our x-intercepts. Jay, you don't have to tell me the answer. Just tell me, like, how do I find x-intercepts? What's like the rule? So for the y-intercept, we plug in 0 for x. So what do we do for the x-intercept? I can't hear you. Put the 0 where? Nope, we have that for the y-intercept. So for the x-intercept, plug in 0 for which one? It's not the x. What's the other letter? Yeah, y. Now, where is y? Maybe she's confused because there's no y. But there is, isn't there? Where's y? The g of x, that's the y. That's the y. So we got to plug in 0 for y. So I'm putting a 0 here. Now, this is what we started our lesson out with today. We're going to undo the things that are happening. If you don't know the order, then just think about order of operations with x would be first add 2 because that's parentheses. Then do the squared because that's exponents. Then do the multiplication, multiply by 4, and then do subtract 1. That's our order of operations. So to undo it, you go the opposite order. So Hannah, what do I do first?
First to get rid of 4.
No, what's the last thing I do over here? It's going to be the first thing I'm going to get rid of. So how do I get rid of subtraction of 1? Add 1. So we'll have 1 equals 4 times x plus 2 squared. Now, Ethan, what do I do? So I just added 1, so that part's done. What am I doing to undo times by 4? I can't hear you. Divide by. Yeah, divide by 4. So we'll divide both sides by 4. That was messy. Okay, so now I have 1/4 equals parenthesis x plus 2 squared. What's the next thing we have to get rid of, Brecht? How do I get rid of the squared? Okay, but I'm not just square root, but plus minus square root of the 1/4 of both sides, but it just cancels over here. Now, if this is another thing that my students did not seem very confident that they remembered, if you are square rooting a fraction, you do not have to square root the fraction as a whole. You can just think about square rooting the top and square rooting the bottom separately. So I'm going to square root 1 and square root 4. Now you guys are going to square root 1 and square root 4. What times what gives me 1? Okay, so the square root of 1 is 1. I don't know why I switched colors. I was in purple this whole time. So I get plus minus. I get a 1 on top. And then on the bottom, square root of 4 is 2. So then our very last step is subtract 2. So we get a plus minus a half and then subtract 2. We got 2 answers. X1, half minus 2. X2, negative half minus 2. So now we just need to know how to find those answers. You might be able to think about it and figure it out, or you might need to find common denominators. That's going to kind of depend on your memory of fractions. If I take a half and then I go down 2, or if I find common denominators, a half minus 4 halves, that's going to be negative 3 halves. This one, if I take a half and I go down 2, that's going to be like negative 2.5 or negative 5 halves. Or we could do it by common denominator, negative a half minus 4 halves, which still gives me negative 5 halves. However you do it, that depends on your memory of fractions. And if you need help with those, we can go over those later. I'm going to put them in order from least to greatest. So negative 5 halves, comma 0, and then negative 3 halves, comma 0. And then finally, we can go to our graph and plot all this information. So if I am going fast, which I am going kind of fast right now, remember you can go just watch part of the video if you need it. I am renumbering only my y-axis. It doesn't really matter which ones you renumber, but I just chose to only renumber my y-axis so I can get to that 15, which is like here. There's 15. My negative 2, negative 1 is my vertex. Negative 2, negative 1 would be here. My axis of symmetry is at negative 2, so I can find a mirror point. The x-intercepts are here at negative 1.5 and negative 2.5. And so that is enough points. But remember, if you need more points, you can always find more points with a transformation table or just picking x's to plug in. I'm sorry the very end of it was rushed, but the new part is just finding the x-intercepts. None of the homework will have anything harder than what we did. It'll only be easier. So if you're finding it difficult, maybe you're overthinking. There's just 6 questions. If you guys want a paper copy, I printed like 10 of them. I have more next door if more than 10 people want them.